Hello and welcome back to the solution videos for the Marquette ACM UPE Programming Competition 2017. We're on to question 6 called Off the Grid, which asks students to write a program to determine if the 4x4 pattern is a valid mini Sudoku solution. So we have these 4x4 patterns here, and they're divided up into 2x2 chunks at each corner as well. It's a valid solution so long as within each row and each column and each chunk we have unique values 1, 2, 3, and 4. So here we see 1, 2, 3, 4, here we see 1, 2, 3, 4, and on this row and on this row, as well as on each of the columns, as well as on each of the chunks. So this grid is a valid solution. Over here, this is an invalid solution in a few ways, honestly. So on this top row, we have multiple 1s. On this third column here, we have duplicate 1s. On this bottom right chunk, we have duplicate 3s. All of these make this an invalid solution. So we're going to be writing a method which takes in this solution as a two-dimensional int array, so rows and columns with the values filled in. And then we need to return a Boolean, true or false, whether or not this is a valid solution. So let's get to it. So here's our code skeleton. And right off the bat, one thing that we're going to need to be able to check whether we have unique values within these different rounds of row, column, or corner is an array called scene values. This is a really good way of checking whether you've got unique values within a set. So the way that this is going to work is we're going to index in to scene values with the index that's equal to our value that we're checking. So if we're checking if we've already seen the value 3 in the current row or the current column, we just index in at scene values at index 3, and if it's true, that means that we've already seen it. And therefore we have a problem and we should return false because we've found a duplicate. Otherwise, if it's false, then we haven't seen it yet, so we'll set the value at that scene values 3 equal to true so that in the future we know that we've already seen it. Hopefully that will become more clear as we go through and use scene values. So first off, let's start by checking all the rows. So we'll loop through each row, row 0 through row 3 when we're talking about indexes. And then for each row, we have to loop through each column. So we're going to check each row here by looping through all of the columns in that row. And for each column, we need to say, have we seen the value at this spot yet? So we can do that by indexing into scene values with the value at this spot in the solution array. So we'll index into the solution array to get the value out, and then index into scene values to get whether or not we've seen it back out. If we have, this if statement will be true, and since we're seeing it again just now, that means that we found a duplicate, and we need to return false. Otherwise, this if statement will be false, and that means that we haven't seen it yet. So this is okay, but we just need to set scene values at our current value equal to true, so that in the future, if we see it again within this row, we know that we have found a duplicate. Then, after we check each row, we need to reset scene values to be all falses. Remember that when you allocate a Boolean array, it initializes to all falses. So we can just redo that again. That way we know that we're starting with a fresh set of falses for each row. We're not checking between each row, only within each row. All right, so that's going to check all of our rows to make sure that they are all unique. Checking the columns is going to be very, very similar, so we'll just copy and paste here. So we're going to be checking all the columns, checking each column. We can change the for loops here, so we're looping through each column, and then for each column we're looping through all the rows in that column. And then after we go through all the rows and see if they're unique, that's when we reset for the next column. Okay, so very similar for checking the columns. Checking the corners is going to be a little bit different. We're actually going to have a different for loop structure, like outer for loop, for each corner. And that should become clear as we go on here. So, for example, let's start with the top left corner. So the top left corner has row 0 and row 1, as well as column 0 and column 1. So we need to loop through those 4 spots and check within that. So let's do that here. I'm just going to copy the structure of up here. Actually, no, we can start from scratch. So we're starting from row 0 and row 1, so up through row 2. And then for each of those rows, we're checking within column 0 and column 1. But we aren't going to reset until after we've checked both rows and both columns in each row with our seen values array. That way we actually are checking 4 values here, 0, 0, 0, 1, 1, 0, and 1, 1. And we're going to be doing the same check, however, so we can just copy paste that part. Alright, the other 4 corners are going to be very similar. So let's start with the top right corner. So the top right still has rows 0 and rows 1, but column 2 and column 3. So we're adjusting the columns that we're checking. So we're starting at column 2, going up through column 4. Oh, sorry, that's the wrong one. I meant to do that up here. Cool. That's all we need to change. Then for the bottom left corner, we're working with row 2 and row 3, but still column 0 and column 1 from top left. So we're going to change the rows to go 2 through 4. And then finally for bottom right, we're going to be doing row 2, row 3, column 2, and column 3. Alright, so this should check each of our corners. And then if it passes all of these without returning in the middle of it with a return false, then we'll just return our true that we have in this it's valid boolean right here. Alright, so let's test this out. We can start by using the valid test case that they gave on the sheet. So this goes 1, 2, 3, 4, 3, 4, 1, 2, 2, 1, 4, 3, and 4, 3, 2, 1. This should return true. Awesome. And then let's try the invalid one that they gave on the sheet. So this is invalid multiple ways. There we go. We just did duplicate 1. And that's the only duplicate row, but one duplicated row is enough to make it be false. Perfect. And we can even just do like a stupid test case here. We can see that all of the rows here are bad. And there we go, return false. So there we go. That's how we do problem 6.